The nanotechnology became one of the fastest growing fields with many diversified branches. Why nanotechnology is so prospective? Despite the diversified applications, the nanotechnology branches have one important common issue: a trend to reach and design things at atomic scale. In this aspect, a deeper understanding of the atoms as the building blocks in nature is necessary. Some nanostructures, for example, exhibit new properties that are not predictable by the existed so far theoretical models. I would like to acquaint you briefly with one alternative theoretical model of the elementary particles and atomic nuclei that shed a new light on the physical processes in sub-nanometric scale. The basic structures of matter, supergravitation unified theory, abbreviated as BSM-SG theory, was developed according to the predictions and recommendation of Maxwell, the father of classical electrodynamics. The theory is based on a new physical model of the ether that have not been envisioned and investigated before. The suggested model is a unique three-dimensional grid structure called a cosmic lattice that has an unique structure and properties. It is responsible for all known physical fields and quantum mechanical interactions. The nodes of cosmic lattice, made of two types intrinsic matter, are held in the pure empty space, a space without physical properties, at a proper internode distance by supergravitational forces. These forces are inverse proportional to the cube of distance, and they may change the sign and magnitude as a function of node distance. At the far field, these forces between elementary particles and material objects propagate through the cosmic lattice and manifest themselves as the Newtonian gravitational forces. The major parameters of cosmic lattice, such as pressure, frequencies, fluctuations, and node distance, are derived and expressed by the known physical constants. The BSM-SG theory can provide a bridge between the Newtonian mechanics, quantum mechanics, and theory of relativity. So it is able to contain classical explanation of phenomena from microcosmos to universe. Now I would like to open a bracket to show one statement of Albert Einstein expressed about the year 1920 and written in his book Sidelights on Relativity, page 23 of the English translation. Recapitulating, we may say that according to the general theory of relativity, space is endowed with physical quality. In this sense, therefore, exists an ether. According to the general theory of relativity, space without ether is unthinkable, for in such space there will not only be no propagation of light, but also no possibility of existence for standards of space and time. The BSM-SG atomic models are one of major derivatives of basic structures of matter supergravitation unified theory. They match perfectly the shape of the periodic table of elements, providing a classical explanation of their physical and chemical properties. In the near field, they create a space microcurvature due to their superdense material structure. The estimated physical dimensions, however, are realistic, so this gives a new advantage for a graphical modeling in a nanometric scale. Let us emphasize the difference between the BSM-HG atomic models and the quantum mechanical models of atoms based on the Bohr model of hydrogen. In BSM-HG models, the superdense matter of the elementary particles in the atomic nucleus causes a space microcurvature of the physical vacuum. This is not envisioned in quantum mechanical models, so they work only with energy levels that appear in a linear scale. Quantum mechanical models are not suitable for working with the dimension of length. The quantum mechanical models of atoms are based on the extremely small atomic nucleus, the size of which is estimated by scattering experiments. However, these experiments have only an angular resolution, not a transversal one. In their interpretation, a priori accepted spherical shape of the nucleus and elementary particles is used. This and other simplified assumptions might affect significantly the derived results about the physical size of atomic nuclei. This slide illustrates the historical problem of scattering experiments. At the time of Rutherford, the scattering experiments used alpha particles from a radioactive decay, which have an energy limitation. So Rutherford extrapolated the results of scattering experiments beyond 25 megaelectron volts. The modern scattering experiments with energies above 27 megaelectron volts showed a significant departure from this extrapolation. This is shown at the upper right corner of the slide. In fact, many modern scattering experiments contain a signature of atomic nuclei with a complex manifold shape. This was discussed in one of my articles in the online Journal of General Science. Today we have enormous experimental data from different fields of physics from which we may reveal logically explainable properties of the elementary particles. The analysis of this data from a different point of view helps to envision the existence of underlying structure of the elementary particles. From the revealed working models, it appears that only proton, neutron, electron and positron have a stable underlying structure. All unstable shortly lived particles, in fact, are fragments from the structure of these four particles. Furthermore, the proton and neutron appear to have one and the same underlying substructure while having a different shape. They are shown at the upper side of this slide. Their superdense material structure is shown by black curved lines, while the proximity fields are in a gray shade. The shape of the proton is a twisted torus, and the shape of the neutron is a folded torus. In fact, they both are formed by two types of helical structures that enclose internal helical structures of two pions and a kaon, but this is not a subject of this talk. But why they are distinguished by charge? In fact, their substructure modulates the cosmic lattice, creating an electrical field lines, and in the near field they emerge from their non-spherical shape. For proton, these lines are detectable in the far field as electrical charge. For the neutron, however, these lines exist only in the very near field, Therefore, its charge is locked in the near field by the strong supergravitational forces. When moving and rotating, however, the neutron exhibits a magnetic moment which is a signature of its locked electrical field. This stays as an unexplained enigma in modern physics. When the neutron is positioned over the proton, it forms the nucleus of deuterium. The near-field lines of the neutron keep it at the middle, but it has a freedom to rotate, and this is very important for the classical explanation of the nuclear spin. It will be discussed later. At the bottom of the slide, the structure of the electron is shown. In fact, it has an internal positron. It is known that the electron, for temperature above the absolute zero, is constantly in motion. From where does it obtain energy for this? When in motion, the electron simultaneously rotates and oscillates, interacting with the vibrating frequency of the cosmic lattice, identified as a Compton frequency. From analysis, it was found that the cosmic lattice exhibits constant fluctuations with wavelength equal to a whole number of Compton wavelengths. In fact, this causes the electron to move with preferable quantum velocities, which appear to correspond to the electron energy levels of the principal quantum numbers of the Bohr atomic model of hydrogen. The supergravitational forces are inverse proportional to the cube of distance, so they are super strong only at sub-angstrom scale, but they are still involved in the molecules and appear as one kind of van der Waals forces. This slide shows the method of derivation of one important parameter of the supergravitational field by analysis of hydrogen molecule and also the deuterium molecule by using the experimentally observed spectral data. The derived factor was verified by theoretical estimate of the binding energy of deuterium. This permitted to make an important conclusion about the energy balance of the stable atomic nuclei.